afternoon, everyone. So, between now and the next several days, I'm going to be dropping some educational videos regarding chemistry, physics, and possibly maths. So, I'm going to drop fast tips on how you can understand the course, for your preparation for JAMB in less than 10 days. All right. So, we're going to be starting with this topic under chemical equilibrium. We'll be dealing with the Chatelier principle. So let's start. So we are dealing on the Chatelier principle. Alright. So what do you understand by the Chatelier's principle? The Chatelier's principle says that, or it states that, if any of the factors of equilibrium are together are imposed on the system will shift in order to annul the effect of the change, or in order to cancel the effect of the change. So what do I mean by that? So let's just state it briefly. The Chatelier principle states that if any of the factors of equilibrium, such as temperature, pressure, concentration, etc., are imposed on a system, the system shifts in order to nullify the effects of the changes, or in order to nullify the effects of the change. So the Chatelier principle states, very briefly, that if any of the factors of equilibrium, such as your temperature, your pressure, your concentration, are imposed on the system shifts. It shifts in order to nullify the effects of the change. Alright. So for this topic, I'm just going to give one example, but I'll make sure that the explanation is very, very in-depth. So I'm just going to make use of this guy, which is I'm going to form a reaction now, XO2 plus O2 to give us SO3. Now this is our normal chemical reaction, right? Let me put it as this arrow. These are your normal chemical reaction. Now, how do you balance it? This is not balanced, quite alright, right? So this is 4 oxygen. Let's just put 2 here. We know with time this is 2 already. You can balance it. Now that means the sulfur becomes 2. Now oxygen becomes 6. That's 3 times 2, 6. So this is 2 here, and this is SO2. So I can decide to put my 2 here, and it's balanced like this. So you have 2 sulfur atoms here, 2 sulfur atoms here, 4 oxygen atoms plus 2 oxygen atoms. That's 6 oxygen atoms. Then you have 3 times 2. That's 6 oxygen atoms. Are we together? So now what's happening here? Now all these are gases, quite alright. You should know they are gases now, right? Now let's go. Now we are dealing with the Chatelier principle, and it is based up on chemical equilibrium. Are we together? So the concept is chemical equilibrium. And what do you understand by equilibrium? Equilibrium is you want something to be stable now, from your physics or whatever. Equilibrium, you just want the system to be stable, you want it to be balanced. But in this case now we are dealing with chemical equilibrium. Now in the Chatelier principle, we are going to do something now. This is 2SO2 plus O2. We have I'm going to put the forward and backward reaction, and 2SO3. Remember that for our chemical equilibrium, we said the rate of forward reaction must be equal to rate of backward reaction. Now together. Now I'm going to call this forward reaction guy. I'll call this backward reaction guy. Are we following? We have the forward reaction and we have the backward reaction. All right. Now let's go. I'm going to just give several questions. One, I would ask, okay, for the following questions, for the following questions, which place or where will the reaction be favored? Where will the reaction be favored? Where will the reaction be favored? I think so. Yeah. All right. What I imply is I want you to tell me if it favors the forward reaction or favors the backward reaction. Are you following? So when you see a double arrow like this, are we together? It means it's a reversible process. You can, once you take your reactant to products, you can as well take your product to what? Reactant. So this is what we refer to as a reversible process, whereby you have a forward reaction and what? Backward reaction. And if you recall, for chemical equilibrium, for a system to be in chemical equilibrium, the rate of forward reaction must be equal to the what? Rate of what? Backward reaction. Alright, so that's that on that. Now I'm going to give several questions. I said for the following questions, where will the reaction be favored? Does it favor the forward reaction or it favors the what? Backward reaction? So 1, increase in pressure favor where? Increase in pressure favors where? You get, let me just put favors where? How together? So we'll be using the acronym favors where as FW, so we can follow. Alright, so increase in pressure favors where? The next one is addition of more O2. Addition of more O2 in brackets reactant. Three, removal of SO2, SO3 now. Removal of SO3. Addition of more O2 favors where? Alright. Removal of SO3, that is the product, favor where? 4, we are going to see decrease in temperature. Decrease in temperature favors where? Alright. Lastly, or 5, addition of catalyst. Addition of catalyst favors where? And let me put the 6th one here. Decrease in the volume of the container. Decrease in the volume of the container containing the reaction or containing the reactants. Containing the reactants where the reaction occurs favors where? Are we following? Alright, so these are the questions that I've seen so far that they asked in JAMB. So these are questions we want to tackle. How to get ourselves for us to understand the concept of the Chatelier principle. It's very interesting, but a lot of people get it confused. So shall we start? So let's give a solution. So some ones I'll be writing it down, but I'll be explaining most of the time. So we are dealing with the Chatelier principle, right? And it says that if any of the conditions of equilibrium is imposed on a system, the system shifts in order to acknowledge the effect of the change. And I told you earlier that equilibrium means you want to attain balance. Just have that word in your head that you want to attain what? Balance. Are we together? Now, for the following reactions, where will the reaction be what? Favored. Now, increase in pressure. Now, we're going to look at something. This side here, this 2SO2 plus O2 is called our what? Reactants. What are reactants? These are the things reacting together. These are the things combining together to give us our what? Products. So we're going to call this guy products. Since we only have one product here, so products. Reactants, I mean this and these guys, they are what? Reactants. Then I mean this guy itself is a what? Is a product. Alright, so this guy is a product. Assuming we add another one, we have products. You get now. Now, okay. So increase in pressure favors where? Now let's go. Increase in pressure favors the side with least number of what? Moles. Now look at your reactants. This is 2 moles of SO2 with 1 mole of what? 2 moles of what? SO2 gas, have you now? Reacting with 1 mole of oxygen gas to give us what? 2 moles of what? SO3 what? Gas. So what are your total reactants here? 2 plus 1. This is 3. 3 ratio what? Ratio 2. How much get that? 3 moles of the reactant compared to what? 2 moles of the what? Product. Now the question says increase in pressure favors where? Now I'm going to be answering it very briefly. Increase in pressure favors the side with least number of moles. Increase in pressure favors the side with least number of moles. So what do I mean by that? Which side has the least number of moles? The product side. Therefore, it favors the what? It favors, okay, don't let me put it this way. Yeah, let me put it this way. It favors the what? Forward reaction. Where is the product? The product is in our forward reaction place. How together? So this is product. Your reactant giving us product is a forward reaction, but your product giving us reactant is a what? Backward reaction. So increase in pressure favors the side with least number of moles. That is, it favors the forward reaction. The equilibrium shifts to the right. And when your equilibrium shifts to the right, which right? It shifts to the what? Right. That is the product side. It's as simple as this. Your increase in pressure favors the side with least number of moles. Where is the least number of moles? At your product side. That means it's going to favor the what? Forward reaction. That is, the equilibrium shifts to the what? To the right, the product side. Then if the question had asked that, okay, what happens to when you have decrease in pressure? Your decrease in pressure is going to be vice versa. Are we together now? For decrease in pressure to be what? Vice versa. Vice versa. Meaning that if it's my decrease in pressure side now, I want to answer. For my decrease in pressure, where will it favor now? Decrease in pressure will favor the side with more number of moles. Do you get how I'm saying it? Decrease in pressure will favor the side with more number of moles. And where is the more number of moles? It favors the what? Reactant side. That is, side with more number of moles. That is, side with more number of what? Moles. Are we following? So it's as simple as that. Now let's go. Now 2. Now 2 says what? Addition of more O2, that is the reactant. Addition of what? More O2 reactant favor where? Now look at it. You are going to assume, it's not even an assumption. We know that for you to have a chemical equilibrium, it must occur in a closed system. What do you mean by a closed system? This is a system that prevents exchange of matter to the what? Environment. Now it makes sense in the sense that if you burn something in a room, in your room now, not outside, you close the door, you close the window, and you are burning something right in your room. You are not allowing oxygen to enter inside. You are not allowing anything to go outside. What happens to you? You become choked. That means there's no exchange of matter to the environment. Everything occurs within that what? Within the room. So that's the idea of a closed system. You are not allowing any exchange of matter to the what? To the environment. So if you are adding more O2, what happens? If I'm adding more O2, that means as I'm adding more O2, there have to be what? More product will have to be what? Formed. Are we together? If I'm throwing more oxygen here, more product has to be what? Formed. It's as simple as that. If you're adding more O2 to the system or any of the reactants to the system, more product has to be what? Formed. Because your reactant will give you your what? Product. So it's as if you are combining more. If you're adding heaps together, what happens? You have a more thicker mixture, you get. So addition of more O2, that is any of the reactants, will favor where? To favor the what? Forward reaction. To favor the what? Forward reaction. That is the product side. Alright, now the third one. You are removing what? SO3. You are removing what? SO3. How together? Now where is SO3? SO3 is where? It is at the what? SO3 is at the product side. Now if you are removing SO3, what happens? I told you that this system occurs in a what? Closed system. So if you are SO2 is combining with O2, to give us SO3. We are now removing the SO3 that is formed. That means those reactants has to what? For them to be balanced, are we together? For them to occur in a closed system whereby there is no exchange of matter, are we together? So if you remove the SO3, those reactants itself, they will have to what? Find a way to what? To react again to give us what? That product that was removed. Do you get? You are affecting the right hand side. So that means those reactant guy have to what? They have to add again to form what? More products. Do you get? So if I am removing SO3 now, if I'm going to remove SO3 from the system, what happens? The system is affected at the right hand side. That means, are we together? So that means I have to find a way to what? Make the right hand side to be what? To be balanced. And what happens by that? So if I'm removing SO3, the system has to find a way for those reactants to combine again to give me what? Products. That means it's going to favor the what? Forward reaction. It's like same thing I'm repeating. To favor the forward reaction, that is the what? Product side. Now the fourth one. Now what's the fourth one saying? You decrease your what? Temperature. If you have a decrease in temperature, where will you what? Favor? Are we together? You're having a decrease in what? Temperature. Now let's look at it. Let's look at this system. Now most times they will be giving you your delta H to be something negative or positive, but in this case you are not giving. Are we together? Sometimes they give you, okay, delta H for the forward reaction is this. Are we together? Now you are going to do something for me. Whenever you have a burning process, and what's a burning process? When something burns in oxygen, for example, C plus O2 to give CO2. This is a burning combustion process or burning process. When something burns in oxygen, your delta H is going to be what? Negative for the forward reaction, and your delta H is going to be what? Positive. Don't worry, I will explain. I said whenever you have a, now most times they won't tell you that, okay, delta H is negative, delta H is positive. They won't tell you. How together? Now you are expected to know that whenever you have a burning process, your delta H is going to be what? Negative. Now I'm coming now. What do you mean by a negative reaction? Or when is our enthalpy change set to be negative? That is when you have a what? Exothermic reaction. And when your delta H is positive, you have a what? Endothermic reaction. Are we following? When your delta H is negative, you have an exothermic reaction. When your delta H is positive, you have what? An endothermic what? Reaction. What's an exothermic reaction? It gives heat to the what? Surrounding. Then delta H is positive, and endothermic reaction means that what? Heat is absorbed, are we together, from the surrounding. Now, if your delta H is negative, I told you that any burning process is an exothermic reaction. Yes or no? Alright. Now, what do I mean by that? If you burn something, now imagine you are in a place that, okay, they are burning tire. What will happen to you? And you are around that place that they are burning tire. You feel that the heat is what? Is touching your skin, right? Together. That means the heat is external. Delta H is negative. The system around you is going to be hot. Yes or no? If you stand anywhere they are burning something, that place around you is going to be hot. Are we together? So that's why we say, okay, any burning process is what? Is an exothermic reaction whereby delta H is what? Negative. That means to the environment, the system becomes what? Hot. The surroundings becomes hot rather. Are we together? The surroundings become what? Hot. The surrounding of the system becomes what? Hot. And if your delta H is positive, you are going to be having what? Cold. And this is the way I interpret my question. You have hot, you have what? Cold. Remember, we are dealing with what? Chemical equilibrium. There has to be a balance. Yes or no? Yeah, there has to be a what? A balance. Now look at this fourth question. It says decrease in temperature will favor where? Now decrease in temperature. This system is hot. This system is what? Cold. It makes sense that for you to attain equilibrium, negative means that something is hot. Positive means that something is what? Cold. So whenever you have a negative temperature, you take it as something that is very high, very hot. So what do you do to a system that is very hot? You try and cool it down. And by trying to cool it down, you are decreasing the what? Temperature. Remember that we said what? Heat has to do with what? Increase in temperature. Now, if you want to eat something, by the time you increase the temperature from 0 to about 100 degrees Celsius, that's boiling of water. What happens to the water? It becomes hot. So if delta H is negative, you are going to take it as something that is very hot, very high temperature. So what do you do to a very hot or high temperature? You try to reduce it down. That means it makes sense for you to reduce the temperature for something that is what? Negative. What do you mean by delta H is positive? When you have a system that is positive, that system is cold. So what do you do? The best way you can affect that system that is cold is by making it what? Hot. You have to increase the what? Temperature. So there has to be a balance here. Are we together? Now the question now says decrease in temperature favors where? Now decrease in temperature. Which system is hot? This is the delta H that is negative. Now, most times they will just tell you that 2SO2 plus O2. You already know that if it is a bonding process, the forward reaction should be what? Negative. Therefore, the backward reaction will be what? Positive. But if you are given that, okay, here is positive, you know that here is going to be what? Negative. Are you seeing the vice versa of that? Now, if you are decreasing the temperature, it makes sense that, okay, what you want to decrease is initially what? High. And where is the place that is high or hot? It is the what? Forward reaction. And the forward reaction is what? You want to decrease the temperature. By decreasing that temperature, you want it to be what? Cold. Therefore, if you decrease this temperature, the system here will become cold. The system here will become what? Cold. Can you see that? I told you they are trying to attain what? Balance. So we know that for decrease in temperature will favor the forward reaction, that is the product side. Are we together? Your decrease in temperature will favor the what? Forward reaction, that is the what? Product side. But assuming the question said increase in temperature, what will happen? For you to increase the temperature, it means that system is cold. You want it to get hot. And if here is hot, here is cold, you're actually making here to be what? From going from cold to what? Hot. There's a transition between the cold to what? Hot. That means if a system is positive, I told you that the ideal sense is for you to what? Increase the temperature. So that means if this question that has for increase in temperature, your increase in temperature will favor the reactant side, that is to favor the what? Backward reaction. Now let's go to the last one. Now the last one says addition of what? Catalyst. Obviously for this process, you know that your catalyst is going to be vanadium 5-phosphide, V2O5 as your catalyst. V2O5 as your what? V2O5 as your what? Catalyst. But your catalyst is not going to do anything to this system. What do you mean by catalyst? We say catalyst is a substance that what? Speeds up the rate of a reaction, or it can also what? Inhibit the rate of a reaction. That means it can also slow it down. But we know that a catalyst speeds up the what? Rate of reaction. Now your catalyst has no effect on here. It has no effect for your what? Chemical equilibrium. Are we together? It has no effects. Are we together? That means your catalyst has no effect. I will explain that why it has no effect now. Now I'm going to turn to the back. Your catalyst has no effect. It makes sense. If you consider, okay, for an exothermic reaction, you consider for your exothermic reaction, how do you know it's exothermic? Whereby you have your product to be greater than reactant. So I'm going to assume that this is 1, this is 2, this is 3. Now this is reactant. And let's assume that this is 1. This is your what? Products. These are your reactants, these things, A plus B, and this is your what? Products. And we have what is referred to as what? Activation what? Energy. And what's activation energy? EA. We know that EA is what? Activation energy. And we know that activation energy is what? The minimum amount of energy required for your reactants to be converted into what? Products. And here you have your activated complex. The activation energy is the minimum amount of energy required for your reactant to be what? Converted to products. Now also note something. Some people make a mistake from this. It is from this guy where the reactant is to where your product is where you have your what? Delta H. That's why we say our delta H is negative. How did I know it's negative? What's my product here? According to this place, it is what? 1. What is my reactant? 2. 1 minus 2, negative. That's why I know that this is the what? Energy profile diagram for what? An exothermic reaction, whereby we have your product to be less than reactant. Sorry, you have your product to be less than reactant. That's when you have your what? Exothermic reaction. Since we know that delta H is what? H product minus what? H reactant. Alright, so that's by the way. Alright, so activation energy is the minimum amount of energy required for your reactant to be converted into what? Products. Now, if you add catalyst, what does catalyst do? Now, let me show you what catalyst does. It's just going to lower this activation energy a bit. It's going to lower it down. Let me draw it very well. Now, this will be your, this still remains your product, this still remains your reactant. What has it done? It tried to reduce the activation energy from here to what? Here. That means the new activation energy is just going to be from this guy to this guy. What has it done? It has lowered the what? Activation energy by providing what? An alternative pathway. So when you have a catalyst, it just lowers the activation energy and provides what? An alternative pathway for the reaction to what? Occur. So it's not doing anything. Did it do anything to your reactant? No. Did it do anything to your product? No. lower activation energy, just lowers the what activation energy. That means your catalyst has no effect. It doesn't affect the forward reaction, it doesn't affect the backward reaction. Its own is just to lower the activation energy. By the time it lowers the activation energy, that means it has increased the rate at which the reaction will what occur. That means the reaction now occurs what faster. Catalyst has no effect altogether. So that answers the question that addition of catalyst favors where it doesn't favor anywhere. It has no effect altogether. So I hope I've done justice to the Chatelier principle. So a lot of these questions, JAM plays with a lot of these questions. They find different ways they can answer it, but these are the basic. Once you can answer these basic six questions, I think it's 5. Once you answer these 5 reactions, okay, we're not done with things. So once you can answer these 6 questions, you can basically understand everything that has to do with that. Now let's go to 6. 6 says that decrease in the volume of the container containing the reactant where the reaction occurs favors where. Now this reaction, we said it is occurring in a closed system. Probably that closed system is a container. What actually happens? Where will it favor? Will it favor the forward reaction or the what? Backward reaction? That's what we want to examine. By the time you decrease the volume of the container containing your reactants where the reaction is occurring, what happens to your what? Where does it favor? Now let's do justice to that. So for question 6, we are decreasing the volume. Quite alright. Volume is decreasing. Now there's a law we know. We know that pressure is inversely 1 over what? Pressure is inversely to your what? To your volume. And this is Boyle's law, right? What does it mean? If my V is decreasing, it makes sense that my P has to be what? Increasing. As my volume is decreasing, there's an increase in what? Pressure. That means volume decreasing connotes or leads to what? Increase in pressure. Are we together? By you decreasing the volume of your container, you are trying to increase the what? Pressure. And therefore, if you are increasing the pressure, we already know that increase in pressure favors the side. Increase in pressure favors the side with least number of what? Moles. Now, judging by this, which one of them has the least number of moles? The product side. So therefore, it favors the product side. It favors the product side. Now, okay, we've done justice to that. So let me just wrap it up with another equation. Say you have HI. Say you have H2 plus I2, hydrogen gas with iodine, to give us something like 2HI altogether. Now this is going to be gas altogether. Alright, so you have this I2. I think iodine is always solid. Yeah, bromine is always liquid at room temperature. So that means iodine is solid, but it's a diatomic molecule now. Remember, all our halogens are diatomic molecules altogether. So this is solid, and I think this should be gas. Yeah, hydrogen, iodine, gas. Alright. Now, what will happen here? Gas, solid, gas. Alright. Now, what will happen here? What will happen here? Now, look at this. If the system says increase in pressure favors where, what will be the answer to this? Increase in pressure favors where? Now, if you look at this, this is 1 mole at the reactant, 1 mole at the reactant. Altogether, there will be what? 2 moles. Equivalent to what? 2 moles. Now, increase in pressure favors where? This reactant, they all have what? Equal number of moles. Are we together? These reactants have equal number of what? Of moles. Are we together? So therefore, our increase in pressure will favor weight. It's not going to favor anything. They have what? Alright. So increase in pressure favors weight. Now, this is going to be a gas. This is a gas. This is a gas. This is a gas. Because we only said pressure only affects gases. Are we together? So that means pressure affects gases. Are we together? Just take note of that it is pressure that affects your what? Gases. Now, increase in pressure favors weight. Now, both of them have equal number of moles. Therefore, if the question has us that where will the increase in pressure favor? Increase in pressure will favor what? Nowhere. No effect. Or no change in what? Equilibrium. No change in equilibrium. Why is there no change in equilibrium? Because you're having equal number of what? Moles. And for increase in pressure to favor a side, it means that side has to be the least number of moles. So thank you guys for watching. Please try and subscribe like and leave your comments so we continue with more aspect on chemistry. Thank you for watching.